So class range versus RFC 1918 addresses. So can anyone tell me what is RFC 1918?
You say that the RFC 1918 addresses was the classes A, B, C.
See, yeah, and these are for the private IP addresses.
Oh, for only the private one.
Private, yes. You
Okay.
cannot use these addresses on your public infrastructure.
Okay, thank you.
It won't work. It won't work. Okay. So if somebody is asking about RFC 1918, you are using in home as well, RFC 1918 addresses on your laptop, on your on Android devices, Apple devices, everywhere. Okay, so these are the class ranges we were talking about: 0 to 127, 128 to 191, 192 to 223. And if you remember, I talked about the multicast addressing, which has the range from 224 to 239. Then we have class E, which is it is not being used. This is just for the experimental purpose.
What is a private address, and where would you
Yeah.
see it? Can you guys give me some examples?
In your local area environment, you will be using RFC 19 addresses. Let's suppose you have multiple hosts, then you have access points, you have server farms, then you have wireless LAN controllers, then you have, so many devices within your network. How you gonna communicate this host machine with this host machine is using RFC 19 addresses.
And also I want to give answer to Hefa that even your routers will have private IP addresses. Think about your home address, your home right now. You have a router, right, Hefa? You are connected to it right now.
Yes.
And it will have one interface connecting to your ISP. That is your public or live IP that you are connecting. That's like your gateway, right? So you're connected to internet through that one IP address. So for me to say, who is Haifa? Let's say I want to talk to you in an internet world. I'm not gonna know what are you using right now in your home. That is your private address. That's your computer right now. You're connecting with us. At this point, I don't know that machine. I don't know that IP address. That is your private. This means I have no knowledge of that. But if you tell me what is your public IP address, then I may know that because I may be able to even ping it or even talk to it if it has any services open. So that's the difference. So yes, routers does have internally, it needs to communicate with internal devices because that's the private IP addresses it's going to use. And for external address, for external, your internet has to go out to the world. It will translate.
Okay, so I will move with the same concept what Danish was saying. So RFC 19 addresses is for our local area communication. But let's suppose if we want to talk to the cloud, the service providers, internet, and everything, then we need a public IP addresses.
So I just wanted to ask about what Danish was saying. So let's just say my home internet router, it has a public and a private IP address. So private to communicate with whatever machines are within the house, but public to connect to the ISP. So it has, so a router has both.
A router has both IPs, yes.
Okay, how about
even not router here. If you have, you know the DNS in your network settings, you have here private IPs. Okay, then here we have some public DNS IP, which is, let's suppose for the Google DNS, it is 8.8.8.8.
Right.
This is public. This is not RFC 1918. The top of that or above of that, we have RFC 1980, your LAN IPs.
Okay, understood. Thank you.
We use these private IP addresses in the businesses and many different, there are different thoughts on, like, if a company is very big or large, it's something that we are going to discuss in the CCNA course, that how do you give it a A address or C address. I'm sure as a network engineer, you need to know that, right, Kamran? That
Yes.
when you're about to set up a network, you will be sitting down, and I'm sure at that point you need to do these decisions. You need to make these decisions. But in home networks, the decision is already taken for you. A lot of times you probably will see 196 and 192 addresses, right? Most of us will see that addresses. So you go in there, you turn on, but everything is done for you, Hefa. So you plug in that router. It says, oh, I'm going to give this public IP address because that router is coming from Comcast or some other ISP providers, and they have already done everything for you. So once it gets that IP address, public IP address, then it started doing the other processes, the private IP addresses inside your home network, the DHCP, DNS, everything kicks in, and it creates these addresses for you, by request. So it's a DHCP because it's automatically assigned from, let's say, 1 to 130, 155, whatever it is, right? The number. And then, of course, when you connect your machines, then that's where the private IP addresses are then connected. And when I was talking that I may not be able to find out what machine are you using right now, what is your current IP address. So if I say, can you give me your IP address? A lot of times when we talk to engineers or we work with them, they say, hey, can you give me an IP address? I want to see what your IP address is. And sometimes they don't mention what IP address they're talking about. So you may say, oh, my IP address is 192, what, blah, blah, blah. Oh, no, I'm not talking about private. I'm talking about your public IP address. So that's the conversation is what I want to kind of like reinforce again, that, when people are talking about IP addresses, then know the difference between public, live, and, private IP addresses.
Makes sense. Thank you.
Another point I want to raise here, a very good real practical implementation for that public IP is that have you ever accessed your CCTV cams from outside?
No.
Okay. Let's suppose we have CCTV cams. This is your home. And we have multiple CCTV cams installed on every part of your house. And we have this access point, which is connected with the ISP. This CCTV cams come up with the software that you will install on your Android or Apple devices. And they will ask you to provide the IP. And that IP is going to be your public IP. When you will hit that public IP using that software, which is for your CCTV cams, you will have the access to these all CCTV cams wherever you are. Okay, so this is one of the basic idea behind why we use public IPs. So it is not always that we are just accessing the internet. No, we can do like this way as well. We can come from the internet to our LAN environment. But there is some kind of mechanism in between. We'll talk about netting and port forwarding basically, and the port forwarding. So I digress here, sorry for that. But just I'm going to give you information that this is also the possibility. Okay, so when we talk about the class A, class B, and class C, which is we gonna use in our LAN environment, and this is the range, 10.0.02 all the way to 255, and then we have 172.16.0.0, then 31.255.255, then 192.168.0.02, 192.168.255.255. So this could be also very good, the interview or the exam question, maybe the range is given and they can ask what range this class belongs to. So just by looking at this, you must have a good idea and understanding that this range belongs to the class B or class C. So what is the deal with number of addresses here? As you can see, we have so many in class C, then somehow in the middle, and then we have very less in the class C. So these are like the total number of addresses we can use using the class A, which is 10 network. If I give you a real scenario or practical implementation, when I was working in the hotel environment, and in the hotel, every floor in the room, every floor we have like 10 to 20 rooms, and in each room we have like 5 beds. And now you can imagine how many guests just in a one floor we have. Let's say 100. And if we have 10 floors, it is going to be 1000. It means how many hosts or the IPs I need to give to every guest. But then we have, if I take the range of this one, the total host I can use 256 minus 2, which is 254. Total number of IPs I can utilize. So this is where we are going to use 10 network, the subnet, where we are going to have how many number of addresses you can imagine this far. So these are the addresses, IP addresses, or the network ID I can assign to my local devices, and then I can allocate to the guest. So another very good example, if you are using your home network, you will notice that you will be given this kind of IP addressing 192.168 range, because we have very less addresses here, and you are not gonna go beyond like 250 or something. But if we are talking about the enterprise network, they will be using all the time this range 10. And then further you can do the subnetting to subdivide these ranges if you want. Okay, and we're gonna hit in the last slide the subnetting, where you will get the clear picture of why we need the subnetting at first place. So how did we get this number? If this is 8-bit, this is 8-bit, and this is 8-bit. This is total 24, which is allocated for your host portion. If you do 2 rays of 24, this is the result you are going to get. Okay, so far so clear?
Yes.
Yes.
Okay, that's fine. Yeah, I just added one security concept, that is infrastructure ACL. So what this is also written as IACL. And in future, when you are going to be a security engineer, you will come across with these concepts. So what basically this is, infrastructure ACL is when we have the router, and then we have behind the router we have local area network, which is using what IPs? RFC 1980. And then we have the service provider here. You cannot trust a service provider person. You can never trust these people, because they are always doing kind of packet tracing or these things to analyze your packets, what is going on. Okay, so sometimes what they can do, they can use the same range. For example, if you are using 10 network in your LAN, 10 network range, let's suppose you are using in LAN. So what if this guy is sitting here, he will give the IP in a 10 network range, and he can then access your LAN environment. You cannot stop them. So this is where the infrastructure ACL concept come into play, which is basically nothing but just the access control list. We are going to discuss and learn this concept a lot in detail, but just I'm going to give you a flyby overview. What is it? IACL. So on router, basically, you are preventing to enter, just a minute, I'll use the proper. You are going to prevent any kind of RFC 1918 addresses entering into your LAN. So this is called infrastructure ACL.
Can I ask you a question?
Yes.
So if we're using a VPN in your drawing, where does that take place? Does it take place at the router level?
Yes,
or
it can take place on the router. When we talk about the VPN can be installed on your router. It can be installed on your computers, your host machine. It can be installed on your ASA firewalls or the firewalls, any kind of firewall devices.
Okay.
So I think let me make it a little clear, Kamran.
Yeah. Yes.
Normally, what is a recommended place to place a VPN? Like, usually when we say, hey, we got an ISP router and that is the main connection that's coming to our building, then we have these, core switches or core networking going on. Usually, what do you think? Where do people put VPNs? And
that was exactly my question. Thank you, Danish. Sorry, I can't speak English today.
That's fine.
No problem. Even me too. Okay, so let's say this is your ISP service provider or cloud. It's not specific ISP. We can call it cloud. And you are wise enough. What is cloud? Cloud is nothing, just the internet. And we know this is not secure. We have organization here called ABC, which is in, let's say in Chicago. Another one, the same branch we have in New York. Okay. If you will do the communication without using VPN, sorry, I'm just digressing here, but just to give you the idea, because I just want to clear my understanding first. Why do we need VPN, first of all? So I want to communicate without using VPN. The chances are you are sending the information in a clear text format. And then somebody sitting in ISP can read whatever is going through the ISP. So this is the concept we utilize with the VPN. So we will deploy the VPN on this part, or can say on this router. And then we will deploy the other part of the VPN on this router.
Okay, that makes sense.
Okay, so means inside your communication is clear text, but as it will hit the egress interface of this router, it is just going to give that your packet some kind of coating or some kind of, some outside shield or kind of thing. I don't want to go in detail, just giving you just layman example. So
that's fine.
kind
Thank
of,
you.
this shield, it just protect whatever inside it here. But when you will hit this router, it will know that this packet is intended for me. It will open that shield and can take a look what is inside.
So that kind of goes back to our ACL part, that we don't want anything to be coming inside from that router, right? That you want to make sure that no private IP addresses, not even a public IP addresses should be coming from that. And that's where the VPN plays a big role, where a network engineer will connect to a VPN, and then from their home machines, now they have actually an internal IP address from that network. Then they can do these things. They won't be able to just connect to the router publicly like that, directly. And that's the mechanism from inside. But then ACL is kind of like the security inside the Cisco devices that they have implemented, that you have to follow that to make sure that it doesn't have any open, for something opening for anyone.
Vulnerabilities.
Yeah, yep. There you go.
Yeah. So this is